later, it will be on YouTube. Hi, everybody from YouTube who are watching. Thanks for joining us. We are looking at the EL-W506T and all of the functions that you can use on the calculator for AP Maths and for the CAPS curriculum. So this is our new beauty. It's really nice. It's just been redone. We've redesigned it. We've had 640 functions on it. So it's a nice toy. And the great thing is that we are going to send each of you one of these calculators to say thank you for joining us and for your time today. So I will send you a feedback form after this where you can just fill in your details, and then we'll send your calculator to you. Okay, so some new functions include the multiplicand function, which is really nice for those really advanced math students, and particularly with students who are going into university and studying maths and engineering. They will need that function later. The highest common factor function, which I'm going to walk you through just now, lowest common multiple, and lots of other cool stuff. So I'm really excited to share this with you. So let's go. Right. So some calculator basics. Obviously, this is the button that turns your calculator on. Your second function, which is this orange one here, is just used to activate all of your orange functions. And you, of course, can switch off the calculator by pressing second function on. Your alpha key is the blue key, and that accesses your stats menu as well as all of your memory keys. So there's some nice things that you can do with your memory keys. For example, you can do a quadratic equation using just your memory keys and then store those values into the quadratic values, so A, B, and C, and then just use the equation. So there's some really nice things. Your mode is here, and that just takes you through the various modes, which I will show you in a second. And then, of course, underneath mode is something called backspace, which BS is not what your kids write, it means backspace. So just so you know the difference. Okay, change allows you to change between your fraction or your third answer to a decimal or a mixed answer question. And then, of course, equals is the one at the end. It just allows you to get your answer. All right, so if we press mode, you'll see that we actually have 9 different modes. So normal does things like fractions, integers, probability, etc. Stats does single data, linear regression. There was someone who requested exponential regression. Sorry, not my forte, but it is there on the calculator and it works very similarly to linear regression. So you should be able to, from what I show you, figure out exponential regression. A table mode, like in a function, it gives you back coordinate pairs. What's really nice about the table mode is that it is unlimited. So you can do so much fun stuff, teaching compound interest, finding factor pairs for numbers for those of you who are teaching the lower grades. So many nice things I'll show you in a little bit. And then, of course, you have complex for complex numbers, which I will walk through briefly. And then, of course, the equation solving mode. So this mode, equation, is not allowed in the Department of Education Pure Maths syllabus. So if you're teaching at a school that is not IEB, then this calculator is actually not allowed. So just an FYI, this is purely designed for more of an IEB or for a technical maths group of students. Okay. Then, of course, your other options on your equation, on your mode, are the matrix option, and you can do up to 4x4 matrices. And I'll show you how nice the matrix mode is. It's really, really easy to use. Just a nice, fun function. I loved my calculator when I was doing applied maths. And then, of course, you have the vector option, which is basically a matrix with just 1x3, and it does cross and dot products. That's very nice for those who are doing technical science or advanced science in university as well. Then, of course, your distribution mode is basically your statistical distributions. So you have normal distribution, binomial, and Poisson distributions, and those you will be able to find all of your cumulative and probability distribution functions from. Okay, so really nice, allows you to get a nice idea of what's going on there without having to go to a table. Then the drill function is really nice for primary schools or for grade 8s and 9s as well. I haven't actually done it here, so maybe what I'll do is just show you briefly on a calculator what that looks like. So I'm just going to share my screen here. So here, if I say 8 for drill, you have two options, math and table. Table is for the younger grades. I wouldn't use it for high school students. So just use 0 for math. And then what you have is a number of questions, and you can use your up and down arrow keys. So up, and you have 25, 50, or 100 questions. And then you can choose between plus, minus, times, divide, or 4 of them together. For the older students, again, I'd use the mixed numbers. If, however, you are doing factorizing with your grade 8s and 9s, I would suggest that you actually just practice your times and dividing, just to get them a good foundation before you start teaching them factor pairs or finding the factors for trinomial. It just makes them feel so much more confident before they start doing that. Okay, so once you're there, press your equals button, and then it's going to ask you a question. So the question is 1 times 8. The questions are all completely random, so you'll never have the same set of questions. There'll always be a different set, which is really nice, so they get proper practice in. And then all you do is type in the answer. So here I'm going to say 8 and equals. It will give me a tick and a new question. If I answer the question incorrectly, so I'm going to type 15 in instead of 16, it will mark it wrong and repeat the question. And the calculator is very patient. It's going to keep asking you until you get it right. So there's no pressure from the calculator. It's really up to the student. If, however, you don't want a student to spend 20 minutes trying to answer one question, you can ask the calculator for help. So if you leave the space blank and you just say equals, it will show you your answer, and then you can learn from your mistakes and move on. So the next time you see 18 minus 2, you know it's 16 and not 15, and you've actually learned something without feeling pressured. Okay, then of course you get another question. What I'm going to do now is just skip through the questions because I'm being lazy, and also I don't want to waste your time here. So you'll see I won't get any marks for these because I'm asking for the answers. So right at the end, let me just answer this one so I don't look so dismal. It's going to say press enter, that's your equals button, and I got 2 out of 25 or 8%. So really nice just to let your students practice on the calculator. And of course, the nice thing is you don't have to mark it. All you have to do is write down the marks. And this function is available on 3 of our calculators. So this is on the W506, which we are looking at now. It's also available on our W535, which is the standard CAPS calculator. And then, of course, and the W535 is really nice for grade 8s and 9s. If you don't want them to spend as much money on a calculator, this is a good option. And then, of course, we have the junior one, which is for primary schools, which is the S25. So if you know of anybody in primary school who likes something like that, or you are in a school with a primary school attached, let me know. I'm happy to send an extra S25 with so that you can pass it on to your primary school students as well. Or, sorry, your primary school teachers. All right, let's go back here. Okay, so fun new functions. The nice thing that I didn't mention is that there's a home button on your calculator. So, so I'm just going to go back to my calculator here. So we were in drill mode. If you press the home button, home will just take you back to normal mode from whichever mode you are in. So it's basically a shortcut. Instead of saying mode and then pressing 0, you just press home instead, you know, because we're lazy and we like shortcuts. Okay, awesome. Let's go back here. The next new function that I want to share with you, and this is not new to you, this is new to the Sharp, is our prime factorization function. So let me go do it on the calculator with you. So if we wanted to find, for example, the prime factors of 153. So we're going to say 153. We press equals first, just to input the number into the working memory of the calculator. And then we say second function, and we're going to press this button. You'll see above it in orange, it says pfact. So if I press exp, then you'll see that it gives me my prime factors. Okay, so that's great. And you've seen this all before, but what's really now exciting is that you have a lowest common multiple and a highest common factor function. So if, for example, I can't remember what my example is on my PowerPoint. I'm going to say I want the highest common factor of 15 and 25. I'm going to say 15, and then I'm going to say second function. Okay, sorry. Second function 2. And then I'm going to say 25 and equals. And that's it. So my highest common factor is 5. So now, if I wanted to say I want the highest common factor of 15, 25, and 35, I can say second function and just add another one and say 35 and equals, and so on. And you can do that with as much character space as you have on your screen. So you've really got a lot of space. No one needs more than that. But just know that you can if you want to, because, you know, we're cool like that. Okay, now you also want to find your lowest common multiple. So your lowest common multiple, I'm going to use the same numbers. So we have 15, and now we're going to use second function and 3. So that's your LCM, lowest common multiple. And then we can say 25, and then second function 3 again, and 35, and equals. And so the lowest common multiple of 15, 25, and 35 is 525. Now, where can you use this? Lowest common multiple is the same as lowest common divisor. So when you're teaching your students about algebraic fractions or just normal fractions, this is something really nice that you can use to work towards understanding that your lowest common divisor is this number. Now we can say 15 goes into 525 how many times? So if I multiply 15 by that answer, it gives me 525. What I do to the bottom, I do to the top, and so on and so forth. Okay, since I'm at the end, I see there's a chat. I'm just going to open it and just see. Dumela, you should be seeing my calculator and not the slides at the moment. As soon as I switch my screen, you'll see my slide again as well. Okay, so you'll only see one screen at a time and not both screens at the same time. Okay. Alrighty, let me switch. I'm going to go back to my slides now. So here we are at prime factorization. So that was the highest common factor example, and then the lowest common multiple example. Is everyone happy with this? Do you have any questions? I see there's another one. I'm just going to check. No worries. Okay, cool. Okay, let me move on. So a really nice other function is your recurring decimal function. And to switch that on, I'm actually going to do it with you on the calculator. Because later you'll see some nice ones. So if we wanted to switch the recurring decimal on, we're going to use our setup function. So we're going to say second function and then math for setup. And you'll see you have a whole bunch of setup functions. I'm going to ignore all of those for now, and I'm going to look at number 5, which is your recurring decimal. Just to go through these, decimal point just allows you to choose between a dot or a comma. It's up to you, really not important. I'm going to show you the name function after this, so don't panic. So here at recurring decimal, we're just going to say 5, and I'm going to press 1 to switch it on. Okay, now I'm sure you want to test that out. So if we said 56 divided by 11 and equals, and we use our change button to change the format. Here's my recurring decimal number, and then I change it again, and you can see my actual decimal. So it's really nice just for walking through what a recurring number is, how it looks, and what it actually means on the calculator. Okay, let's go back to my slides. So here, let's talk about name. So here you can actually name your calculator, which is awesome, particularly if it gets lost with students, and also just to give the students something to personalize it. Now you'll note that you can only use letters and the numbers 1, 2, 3, 4, 5, 6 to 9. So if I do it on my calculator, here you'll see my calculator now. So if I say second function math, and I choose 7 for my name, I can choose a letter by using my up and down arrow keys. Okay, and then when I'm done selecting my letter, I choose my right arrow key, and then it will give me my next letter. But this way, I'm going to be very lame and just do this. take up too much time doing this. There you go. There you go. Okay, so when you're done with your name, you've got quite a lot of space. It goes all the way across down to the bottom. You can press equals. And then what it does is if you switch off your calculator, you can say second function on, and you'll see your name appears underneath it. There, let me do it again for you to see. There's your Sharp that you wrote. Okay, awesome. Let's go back here. Okay, so that was a name. Now let's talk calculus. This is a really nice shortcut on the calculator. It doesn't do indefinite integrals, it only does definite. And depending on the size and complexity of your integral will depend on how long it actually takes you to calculate what your integral is. So if I'm going to do it on my calculator, right, so my integral is on this button here. So I'm going to say alpha and my integral, because my integral is blue, so I need to use my blue key. Let's put in -3. Remember not to use your minus button to do a negative. You need to use your negative button to do a negative number. That's just, otherwise it's going to give you an error. And then if we go up till say 7, and then we'll press our right. It's not the same as my example on the screen. You know what, let me just do it so that it is. I don't want to cause confusion later. Okay, and then here you go. So to make an X, the lazy way is to press your RCL button twice, and that will just make an X on your screen. If you want to do it the long way, all you would do is say alpha and RCL. Same. Okay, and then you can press X squared. Oh no, sorry, we did X to the power of 4. So let's do to the power of 4. Right arrow key, -4. And equals, and it's going to calculate it for you there. What did I do that's different? So you can see, sorry. Oh, man. Sorry. Okay, so you can see on the calculator that that is the answer. I'm going to go back to my PowerPoint here. Oh, that's fine. It's completely different. Okay, sorry. Okay, so you can see that that's quite a nice, easy way to do your integrals. And of course, you can do differentiation at a point as well. Okay, so if I do, that's what I was actually doing. Okay, so here, if I wanted to do the derivative, I can say alpha and this button over here, and then I just put in my equation or expression up here. So using my x, I can say x to the power of 4 -4, and we're going to do it at point where x is equal to 2 and equals. Now you'll see that it's got comma dot 5, and that's because it doesn't do it as a differential rule. It uses the Newtonian method, which is basically I don't even know how to explain it, but basically it approximates the answer, which is why you get that. So if you did it by hand, you would see it would be 4x to the power of 3, and then you would substitute in 2, which would just give you 32. Okay. Kebo, I see your raised hand. I don't even know if I said your name right. Do you have a question? Do you want to type it into the chat? I'll wait for you. Are there any other questions here so far? Here is a good point to pause. You are a very quiet group of teachers. The last one, my chat was going crazy. So just checking. Is everyone happy? Are you all good? Okay, fantastic. I'm glad to see that. Awesome, awesome, awesome. Do you want me to repeat this question? Can I do it again? Let me repeat the derivative and the integral just so that you can see here. So if I did an integration here, again, remember you are going from a point, so at the end of your integral to the top of your graph. Remember, it must be in ascending order, so from smallest to biggest. So if I wanted to say between 1 and say, let's use pi, and we'll do a sine. I'm making very complicated nonsense here. I'm just going to say sine x. Okay. Now you'll see when I ask this question that it's going to take a bit longer. You'll see on the screen it says busy, and then it will give me my area between 1 and pi of sine x. Okay, if I wanted to find the derivative, so I can say, oh, remember that I'm in degrees here and not in radians. So this question, I should have probably set my calculator to radians before I did this to get a better accurate answer. Okay, let's do the derivative. So if I say the derivative of sine x at 30, okay, because I'm in degrees, then that will give me my area or my derivative at that point. My gradient is 0,01, so it's pretty flat, which you can talk about the curve of the graph and so on and so forth. Alrighty, cool. Everyone happy with this? I don't see any chat questions, so awesome. Okay, let's go back to my PowerPoint slide here. Right, so speaking of, here's degrees, radians, and gradients. So here's where you're talking about your angular and circular movements and all of that sort of stuff. And the calculator makes it so easy to convert between the various degrees, radians, and gradients. So I'm going to show you that quickly on the calculator so you can actually see. So say, for example, we have degrees. We have 30 degrees, and we want to convert them into radians. So we can say 30. And then all we're going to do is press our second function button and our decimal point. Sorry, I haven't pressed second function yet. And then decimal, you'll see above it in orange, it says DRG with an arrow. So it's telling you you can convert to the next one. So here, 30 degrees is 1/6 of a pi radians. Now, if I wanted to go from radians back into, you'll see on your screen as well, you have radians over there. If I wanted to go back from radians to degrees, let's say I have 3 pi over 4 radians, then I can say second function, and again I'm going to just now convert it into gradients, and second function decimal, and now it's my degrees. So 3/4 pi is equal to 135 degrees. Is everyone happy with that? What you can do, and I'm going to show you this very quickly, is you can actually save this function, the second function degrees, into your D1 or D2 or D3 keys. These are your shortcut lazy keys. They are for your favorite second function functions. Okay, so if you know you're going to be using or you're going to be converting between degrees and radians a lot, then you can save it into this D key and then use the D key instead of saying second function degrees. It's purely lazy. That's what it is. Okay, so let's save it. So we're going to say store D1. Okay, and then we're going to say second function and degrees. Now, if I wanted to convert from, say, 45 degrees to radians, I can press D1 instead, and it will automatically do it for me. It's just a really lazy shortcut option for you. And remember that you cannot save a formula into these D keys. They are only for functions that are already on the calculator. Okay, I see there's a question here. Okay, well, no, this is really grade 10 to 12 maths here. I will do a primary school one for you. So if you are not happy to be part of this, you're welcome to leave. I promise I will not take any offense. I will just send you a primary school calculator instead. Okay, thank you for joining us. We appreciate your time. Let me take you back here to degrees so my calculator is normal. Okay, let's go back to the slides. Okay, so following on from angular momentum and your degrees, radians, etc., you can do time calculations on your calculator. So there are actually 3 different time options. So I'm just going to walk you through them on the calculator and then we'll go back to the slide afterwards. So the first one is that you can convert your minutes into hours. So what you do is, say for example, we have 470 minutes. Okay, we're going to press 0. I just want to press on here. So 0. And then underneath your BS button is DMS. So 0 is just your hours placeholder. And that's just to tell the calculator that we are working in the minutes section. And we're going to say 470. And then we just say equals. And that's it. And that gives us 7 hours and 50 minutes and 0 seconds. Okay, now if you wanted to make that an hours answer with a decimal or a fraction, what you would do is say second function and then DMS, and that will convert your hour notation or your time notation back into a fraction format. So then you can say change, and that will just change your answer to the decimal or fraction answer for you. Okay, now the next example is a Susie train station question. Really nice for Mathlet here. So say, for example, Susie gets on the train at 10:15 in the morning. She gets off at 12:30. How long was she on the train for? So what you can then say is 12, because we put the later time first. Then we press our DMS button to make our hours. And now we're going to put in our minutes, which is 30. Then we're going to say minus, and then 9, DMS button, 45, and equals. And that's it. So Susie was on the train for 2 hours and 45 minutes. And again, if we wanted this in just our notation, then we can say second function, DMS. So she was on the train for 2 3/4 of an hour. Okay. The last example is how long does it take me to get somewhere? So say, for example, we wanted to drive. I'm from Joburg, so I'm going to go visit those guys who are in Cape Town. Hello, guys in Cape Town. And I'm going to come visit you. So I'm going to drive 1,700 kilometers. That's a guess. You live on the very edge of Cape Town, okay? And then I'm going to divide it by how fast I'm driving. So don't trial my husband, but I drove at 134 k's per hour. Woo! I hope I don't get fines, okay? And then we say equals, and that gives us 12 hours and something. And if I change that, 12, I'm still not sure, maybe 40 minutes, I'm guessing. So what we can do then is again use our second function, DMS button, and convert it back to our hour notation. So 12 hours, 41 minutes, and 11.64 seconds, plus however long I take. Okay, so really nice time functions on the calculator. Here is a good time. Does anyone have any questions yet? You're all still happy. I haven't put you to sleep with my very boring voice. Nothing. Okay, you are all asleep then. Okay, awesome. Let me go here. Cool. I'm going to take this one. We did that one. And okay, so this one is really nice for probability. So I'm actually going to open up my calculator again and show you here. So on your calculator, you have a random function. So if we press second function and 7, you'll see you have 4 different options. So random does random decimals between 0 and 1 to 3 decimal places. If you are teaching Math Lit and you know you have to do that in the beginning of the year, you do that practice numbers function where they have to practice rounding off and all of that stuff. This is a great function where they can just practice on their own, rounding off as well. Then you, of course, you have the dice function. So that just gives you numbers between 1 and 6. Let me actually show you because we can. So if I press 1 and then to roll the dice, I just press equals and that's it. And then I have all of these great numbers that I can roll the dice on. I'll give you some suggestions for playing around with this. So what I want to actually show you now is the last one, so second function 7. So here, number 2 is a coin. So it's not going to say heads and tails. It's going to say 0 and 1 because it's a math coin. So on and off, basically. Same probability. Okay. The last one is your random integer. So if I press 3, it actually allows you to choose between which 2 numbers you would like to generate random numbers from. So I love doing the lottery with students. I think it's a lot of fun. They all get heavily involved. So that's a really nice game, particularly to introduce the probability to them. So if the lottery, you can choose numbers between 1 and 52. We're going to say 1. And then over here is your magic X, Y button. That just allows you to put in coordinates on the calculator or to separate 2 points. Okay. So you've got 1, 52, and then you say equals, and then you can generate random numbers between 1 and 52. So what I will do with students is ask them to write down their 6 random numbers between 1 and 52. And then I put the calculator up and I generate the lottery numbers on the calculator. And then I ask them to circle the if they got that number. So I have yet to have a student who got all 6 numbers, but it is a lot of fun, and it's a great way to introduce the idea of branch probability and the fact that your odds of winning the lottery are very, very low. So if you do use this method to pick your lottery numbers, I would like chocolate, and you win. Okay, I want chocolate. Just FYI. Okay. Okay, cool. So some other nice things that you can do on your calculator. I have written down suggestions here. Sorry, I haven't actually. But some other nice things that you can do is to set up a tally table. So ask all of your students to generate the number on the calculator. And then to say, okay, how many people have got 1s, how many people have got 2s, how many people have got 3s, and then to do relative frequency versus theoretical probability. And as the more numbers that they generate, the closer they should get to their theoretical probability on the calculator. So it's a really nice way just to share this exercise with them and give them a chance to play around with probability. I think half the problem with the probability section is we always run out of time. It's at the end of the year, and we're a little bit afraid of teaching it, and it's actually such a nice section. Sorry, I did a stats degree, so I like probability. Okay, cool. So the next thing that you can see here is permutations and combinations. Okay, so this was also one of the things that was requested by everybody. So permutation, the difference between a permutation and combination is that a combination, the order doesn't matter. So you have much less choices than if the order does matter, which is a permutation. So I always like to go onto the calculator because there is a short way to do it and just check which one is which. So if I remember, C is for combination and P is for permutation, I've got it. Okay, so here's my little illustration for you. And it's just a nice way to remember the difference between the two. So a combination is you just chucking all of the ingredients into the bag, whereas a permutation, the order of your ingredients matter. And so if you put in your butter and sugar before you put in your eggs, or if you whip your eggs first and then put in your sugar, you're going to get a cookie versus a meringue. Sorry, I like baking. That's a good example. Okay, awesome. All right, so let me show you how to do a permutation on your calculator. So here, I'm going to find my calculator for you. Say, for example, you have 4 different elements and you have 3 spaces that you want to put them into. Okay, so we're going to say 4 is your n, then we say second function and 6 permutation. Do you see in orange it says P, and then of course got the little R next to it. So 3 is our spaces available, and we say equals. So you have 24 different ways of lining up those 4 ingredients into the 3 spaces. Okay, if we did a combination, we would say 4 second function, and now number 5 it says C and 5, and then we say 3 and equals. You'll see there are only actually 4 different ways to put the 4 ingredients into the 3 spaces. Okay, or into a bag of 3 bags. Does that make sense? Any questions yet? We're all still happy? Great. Oh yay. Hi Angie, how are you? Awesome, awesome. I'm glad to see you waving hands at me. That's good. That's a good sign. Okay, that's combinations. All right, let's talk financial maths. Hello, everybody. Wait. Okay, awesome. All right, so there's a couple of things with financial maths, and one of the things that we added to the calculator was that you can do percentages in 2 different ways. Okay, so the first way is the way that Sharp has always traditionally done it, which is to add, it's the shortcut percentage version. Okay, so if I wanted to say I have something that cost 120 Rand and I need to add 15% VAT, then I can say 120 plus 15 second function and 1. And now I can see that it is 138 Rand. Okay, so that's the short version of doing this. Okay. Now we want to do a question with compound interest, for example. So say we have 1,000 Rand, and we have 1 plus, and say our interest rate is 6%. If I did this now, you'd see it would give me an error. So we've added another percentage function. So you're going to go to math, and over here to number 6, you press 6, and now it will allow the percentage function in there. So it's going to make that a 6% instead, and then close your brackets, and then we say to the power of, let's say 5 years, and there's your answer now. Okay, so that's the difference between the two percentages. Again, if you're going to be doing this, you're going to be using that percentage function a lot, what I would suggest is, again, to store it into your D1 keys. Okay, I see there's a couple of questions. Let me go and answer them. Okay, awesome. Morning, Temba, how are you? Okay, great. And then now let me see. Oh, can I re-explain computation? Sure, no problem, Deduzi. So what we've got here, let me go back to my screen. Okay, so again, just briefly, just to redo this, a combination, the order doesn't matter. So if I took 4 students out of the class, it doesn't matter how I line them up, as long as there are 4 students out of 20. Okay. If I take a permutation and I take 4 students out of my class, there are however many different ways to line up those 4 students in order. So one of the previous workshops I did is I said to the teachers, what you can do is actually take 4 kids out of your class and line them up and say, okay, so this is a combination, they're all in a group, right? But if I line them up, I can have Susie, Jack, Jill, and John, or I can have John, Susie, Jack, Jill, or I can have Susie, John, Jack, Jill. Or, do you know what I mean? So permutation, it matters in which order Susie, Jack, and John and Jill came. So if it's a race, then it would be a permutation. But if it was somebody winning a lucky draw, then it could be a combination. Does that make sense? Do you feel better about that section? If you do have more questions, I'm happy to sit with you afterwards and work through it with you as well. Okay, so let me go back here. That's the financial formula. Okay, and then now this is fun. Okay, so what we're going to do now is go into the calculator, and we are going to teach financial maths using our table mode. Yes, you can do that, and it's awesome. So we're going to go to table, which is 2. Okay, let's say we start with compound interest. So we have 1,000 Rand, because that's my favorite example. Open brackets, sorry, simple interest. I'm going to say 1 plus. Here, I'm not going to use that percentage function. I'm actually going to put it in a fraction form. So I'm going to say 5, down arrow key, 100, and then right arrow key to get out of my fraction, and then times. And instead of putting in a value for x, I'm going to type in, instead of putting in a value for n, I'm going to type in an x instead. So we're going to say RCL, and I'm going to close my brackets. Okay, so I'm going to ignore function 2 for now, and I'm going to leave my start and step as they are because, I'm lazy. Okay, so I'm just going to press equals, equals, and here you will see all of your compound interest. So after 1 year, I got 50 Rand. After 2 years, I got another 50 Rand, so I earned 100 Rand in total. After 3 years, I earned another 50 Rand, so I have 1,150 Rand, and so on and so forth. You can see your table is unlimited. So how long will it take you to double your money? 20 years. How long does it take your money to triple? Again, just press the buttons until you get there. Okay. Now, what's really nice about the simple interest formula is that it lends itself to depreciation as well. Because your x is at the bottom, when it becomes negative, it's actually depreciating. So here you would have simple depreciation just by going up into your negative integer side of the calculator. Oh yes, doesn't matter in which direction you go, and it doesn't matter where you start. You can go for as long as you like in either direction. When you get it, you can test it and tell me if you ever get to an end of something. But I had a friend who tested it for a while, and she just never, I think she did it for 5 minutes and didn't run out of space. So you've got a lot of space. Temba, is there a question that you had? Do you want to type it into chat, or you just say sharp? Okay, cool. So now what I want to do is go here. I'm going to leave my my simple interest as it is. And I'm actually going to add a compound interest into my function 2. So I'm going to use the same values. Open brackets, 1 plus 5 over 100. Right, arrow key. Now, what I'm going to do is I'm going to close my bracket and put in my exponents. And again, I'm not going to put in a value for n. I'm going to type in x instead and equals. And here again, leave start and step as they are. So we're just going to say equals equals. Now, initially, you both have 1,000 Rand in both accounts. After 1 year, you have the same amount because the interest is the same. But after 2 years, here you can see your compound interest grew by 2.50 Rand more than your simple interest grew. Okay, and that is because you are taking 5% of the previous value and not 5% of your initial value. Okay, so that shows you the difference between simple and compound interest. And again, there's so many nice questions that you can ask here. You can say, when does your compound interest double the value of simple interest? I didn't actually check the answer to this. Thereabouts. There you go. That's where it goes. So after 35 years, you will have double the money in your compound interest account versus your simple interest account. Okay, everyone happy with this? There's no questions? Okay, I could not see where you got your X after the interest rate value in your calculator. Oh, sorry, Timber. The X is your RCL button. So you just press that twice to make an X. Okay. Cool. Let me go back here. Alrighty. Let's talk statistics because it's so much fun. Okay. So I'm going to share my calculator with you again. And we're just going to make up. Okay, so I'm going to press mode and then I'm going to press 1 for stat. And here you have a giant menu, single data, linear regression. This one here, number 2, is for quadratic equations. So it's really nice. There's a really nice shortcut for that, which is in the full manual. So if you'd like me to send you the full manual, it works in a similar way to linear regression. So I'll walk you through it after I've done linear regression. So if we press 0 for single data, you can see you can type in your X values. So we're just going to say 85 equals 36 equals, I'm really just making up stuff here, 45 equals 75 equals 63 equals, let's do a couple more, 74, oh, bad one, and last one, cool. Let me do one. Okay, so you've got all of your data, then we can say change. So change just changes between your data screen and your calculation screen. Now here I see I typed in 15 and it doesn't make sense with my rest of my values, so I want to change it to 51. So what I can do is I'm going to highlight the 15 and then I just type 51 over it and press equals, and you'll see now that the 15 becomes 51. Okay, so really easy to edit your data. When you are done, you press change. Okay, now here's the really hard part. Are you ready? We're going to press, there we go, alpha and 8, and that gives us our statistics menu. You'll see above 8 in blue, it says stats. Now, number 1 is blacked out because you can't do it in single data. Okay, so we're only going to use 0. So we're going to press 0, and that's it. That's all there is to stats. So you'll see there are 9 observations. Our average is 63,777. Our standard deviation is 18.14. Remember to use the sigma x and not the SX because the formulas are different. Okay, so we use the standard formula in high school. So that's just, you just need to make a note that it's the sigma x and not the SX. There's your sums. And of course, your 5-number summary. So your minimum, quartile 1, max, median, quartile 3, and your maximum. It's all there for you, easy peasy, nothing to stress about. Okay, so that's stats basically. Can I show you linear regression? All right, cool. So we're going to press mode and then 1 for stats. And now we're going to choose 1 for your straight line. Again, I'm just going to make up values here. You can practice using the examples that I've got in the presentation that I will send to you. Okay, so here you have 2 options. You can either type in all of your X values first and then press equals after each one. Or what you can do is type in your coordinate pairs. Now, that's the way I like to do it, just because it makes sense that it's not just X values and Y values and the order doesn't matter. They are actually a pair. They belong together. They're husband and wife in inverted commas. Okay, so here what you can say is 1, and again, we're going to use our XY button, and then we're going to say 3, I'm making this up, and equals, and then we're going to say 2, XY button, and 7, and equals, and let's just do one more, 3, XY, and equals. Now, that won't give me a perfect line, but that's good, because we don't actually want perfect lines. When you are done typing in your data, press change, and there's your screen. Again, we're going to use our alpha 8 key, so we're going to say alpha and 8, and there's all of our menu. Again, if we say 0, it will give us all of the summary stats for both X and Y values, as well as your minimum and maximum. Okay. If I wanted my linear regression formula, I'm going to say alpha 8, and here you see this line is not blacked out anymore, so we're going to press 1, regression value, and there it is. So my gradient is, my y-intercept is -1/3, my gradient is 3.5, and my correlation coefficient is pretty close to 1, 0.99. So all there for you, really, really easy, super easy to use. Are there any questions for stats yet? No. Okay, cool. Just briefly, because I see it's already 10 o'clock and we still got matrices to do. For the quadratic patterns, it works exactly the same as the linear regression. So you have your X and your Y. Your X is your term position, your Y is your term value. So all you would do is type in your term value, your term position and your term value. You need at least 3 points in order to get your formula. When you are done with that, go to your menu, and again you're going to use so it'll be alpha 8 1, which is your regression line, and that will give you A, B, and C. Just note that the A is the y-intercept and the C is the x-squared coefficient. So you need to remember where you put those in the formula. But since you can actually see the line here, you can see A plus BX, it tells you exactly how to write the formula down by substituting in A, B, and C. Okay, so that's just really nice shortcuts. I don't often share it because I feel like it's probably better that just the teachers know. And it's something that your students might be impressed with right before the exams are starting and they're all panicking. Okay. You can also use it to predict your X and Y values. So when we do extrapolation or interpolation, you can use that as well. Let me show you quickly. So say, for example, my X value is 5 and I'm looking for my Y, then I can say second function and Y, and that will give me my answer. Okay, if I'm looking for if my Y value is 45 and I want to know what my X value is, I can say second function X, and that will be the when it's in brackets like that, I think it's recurring. Okay, so that's just the difference between and finding your values there. Are there any questions here for stats before I move on? Are you all still happy? You're not tired of my voice yet. Okay, great, fantastic. Okay, let's go back to my presentation. Yeah. Okay, so that's stats in a nutshell. There's linear regression and the example, and I've given you all the different things. I want to go briefly into distribution mode, just so that you know how to deal with it. Okay, so on your menu, you're going to press 7 for distribution. So it's mode and then 7. And then you have 3 different options: normal, binomial, and Poisson. So let's just do a normal option, and we'll do the normal probability distribution function. So we're going to say 0. So your x is the x value that you're looking at. So let's call it 8. And then we say equals. Your mu is your average of your data set. So let's call it 5. And your standard deviation is 7. And that will give us the probability of that particular point in that distribution for normal mode. Okay, so very easy. You can see it's just literally point and click and to put your values in for that as well. Okay. Any questions there? You're still all happy? Awesome. Okay, so let's walk through table mode. What I want to just show you briefly is a tan graph. And that's really nice. Again, so let me just say mode and 2 for table, and we'll just draw a tan graph. So we're going to say, oh, did I make a complicated tan graph? I did too. Okay, let's do a complicated one because we're all high school FET teachers here. We hope. So 3 tan, open brackets. Again, to make an X, you're going to press your RCL button twice. 1, 2, and then let's shift it over 30 degrees and close brackets. Okay, and we're going to say equals. I'm going to ignore my function 2 for now because I don't feel like it's necessary to complicate things. So we're just going to press equals. Again, let's leave our start at 0 for now. Obviously, you don't want to draw a tan graph in steps of 1 unless your child is in detention and you're proving a point. But if, for example, you wanted them to draw the graph, so to actually get the curve, you could do it in steps of 5 or steps of 10 or 15, depending on how much of a curve you're actually looking for. So I'm just going to do 15 because for a tan graph, that's quite a nice option. And again, here we go. So 0, 0, there's my intercept, and then of course if I keep going, there's my asymptote. So my asymptote actually looks like an asymptote. So when they see a striping line at x is equal to 120, they know to draw a striping line on the graph as well. Okay, awesome. And again, your table is unlimited. You can go for as long as you like without running out of space ever. And even though we started at 0, again, you can go back up to your negative integer side. It doesn't matter where you start, and it doesn't matter what size your steps are. So when you are doing something like where does a sine graph intersect with a cos graph, and you have the 2 functions, then you can find a general by doing a bigger step and then going back and changing your step into something smaller as well. Okay, I see there's a question here. And yes, I can send you a manual, definitely, with pleasure. I'll do that for you. Alrighty, so that was tan graphs. So something else that's really nice to teach, I'm not going to actually do it on the calculator, but I do want to share this with you because it is such a nice function. Okay, hang on, I see lots of questions here. Okay, I'll send everyone a manual, okay? I promise. I'll send it probably tomorrow, if you don't mind waiting till tomorrow. Okay, awesome. Yay, that you're all excited to have a manual about the calculator. That makes me happy. Okay, cool. So one of the nice things that you can do on your table function is actually to teach where the cast diagram comes from. So when I was in high school, all the teacher said is, here's a cast diagram, and these are the rules, which worked for me because I like rules and I can follow them. But for a lot of students, they wanted to know where these rules came from and why it's important. And I think that that's something that we should actually consider as teachers. Sometimes the kids want to know. So this is really just a self-discovery exercise. What you can do is type your sine graph into your calculator. So you can see there's my sine graph. I ignored function 2, I left my start as 0, I made my step 15, and there are my coordinates. Now, what we did on the calculator is we went and looked and plotted where the coordinates were negative and where they were positive. What I'm seeing here is that you should probably give them this table so that they know the points where they stop and start, especially if you're doing this from a very beginner grade 10 perspective as well. Okay, so just give them the table like this. And then what you can do is do it for cos and do it for tan. And what they should be able to do is look at the table and go, okay, cast, C is for cos. So my cos is positive between 0 and 90, and it's negative between, oh, sorry, all is, oh, goodness. So you know what I mean. I'm confusing my cos table. So sorry, cos is negative between 360 and 270, but also between 0 and negative 90. So it's something that you loop around the table as well. Okay, so just make sure you explain it better than I just did. It is on our website, and I'll give you a link to the website afterwards. Okay, finding factor pairs on the calculator. This is also, again, really nice for teaching factorizing pairs. So on your calculator, say, for example, you wanted the factor pairs of 45. You can say 45 fraction, and then you can press RCL twice. Okay, so it's basically a hyperbola graph, and we're just finding the factor pairs of your x and y coordinates. Okay, so leave function 2 for now. Leave my start at 0. Obviously, I'm going to now make my step 1 and not 15, because I will lose all of my factor pairs if I left that 15 and press equals. Again, anything divided by 0 is undefined, which is your asymptote. This is a really good reminder for grade 8s and 9s, to just teach them that that line means undefined. So when that they get to grade 10, they know, okay, a stripy line means undefined, and in grade 10 they learn the name is an asymptote. Same. Okay, so I have factor pairs here, 1 and 45. 2 is not a factor pair because it has a decimal answer, so 22.5 is not a factor. 3 and 15, 4 is not a factor, 5 and 9, 6 is not a factor, 7 is not a factor, 8 is not a factor, 9 and 5. So now I have all of my factor pairs and I can stop. Okay, if you are teaching trinomials, then what's really nice is you can say to them, okay, the sign at the back is a plus, the sign in the front is a plus or minus, and when the sign at the back is a plus, it means my signs in both brackets are the same, so I must add my two numbers to get my middle term. If my sign at the back is a negative, it means my signs are different, and I must take my one factor away from my other factor. So I must make one column a positive column and one column a negative column. And that's a really nice way for doing basic trinomial factorizing with your grade 8s and 9s before you introduce the concept of an a value greater than 1. Okay. All right, how are you all feeling? Are you all okay still? You're still all awake? I know it's been an hour already. Yay, hello. Awesome. Okay, I see I've got about 20 minutes left, so I'm going to fly through these. The complex numbers is really, really easy. So let me just walk you through all the basics of that. Let me go to my calculator. So let's press mode and 3 for complex. Okay, so if you look, your DMS button has got a little sign underneath it that says I. If I press that, it now gives you the I in complex numbers. Okay, if you wanted to do your hypotenuse and angle, then you could use this button here. You'll see the little angle sign. So here we are in, your XY says you are in polar coordinates, rectangular coordinates and not polar coordinates. So if, for example, I had 6 plus 3i, right? There you go. So that's what it'll look like. If I want to convert that into polar coordinates, I can just say second function and 8. And now you'll see on your calculator it says r theta, and that gives you your hypotenuse, which is 6,7, and the angle, your arc angle. Okay, again, if you want to convert backwards, all you have to do is say second function 9. So you can just change between the two different ways of doing complex numbers. Now, the other thing that you can do with complex mode is to find your conjugate. So you can press math, and there's your conjugate. So we can say 0. And then if I wanted it for 3 minus 5i, it will give me my conjugate value as well. Okay, awesome. Are we all happy so far? That's pretty much what complex numbers boils down to, and then switching between the polar and rectangular coordinates as well. The nice thing is you can use the polar and rectangular coordinates in home. I'm going to show you quickly. So this is just a shortcut for, we call it a shortcut for Pythagoras, but it's just converting your real values and not your imaginary values between your polar and rectangular coordinates. So if, for example, my x coordinate is 5 and my y coordinate is 12, and then I say second function 8, it will now give me my hypotenuse and the angle my hypotenuse makes with my x-axis. Okay, now what's really nice here is that these values get stored into your x and y values. So if I go to my memory summary page, which is just alpha 9, it will tell me my x is 13, which is my hypotenuse, and my y is my angle, which is 67, blah, blah, blah. So now if I wanted to do a calculation with my hypotenuse, I've actually got it saved into my memory key. Okay, it's just a really nice digression that I'm showing you here, but the memory keys are really super handy for you as well. Okay, so that's that one. Go. All right, and then of course, if you want to change between real and imaginary values, you've got those options on your menu as well. So if you wanted to use real, you just press 2. If you wanted the imaginary value, then you would press 3, and so on. Okay, so really simple and easy to use. Yes, I see there's a question here. Ah, thank you, G. I must go and read my my technical maths notes. Okay, so hypotenuse is a modulus in technical maths, just for everyone to know. Okay, let me show you equation mode. Okay, so we're going to press press mode, and then we're going to choose for equation. So here you have 4 options. 0 is 2 variable linear equation, then 1 is a 3 variable linear equation. Okay, so 2 variable linear is x and y, 3 variable linear is x, y, and z, but you cannot have any exponents in your equation. Okay, quadratic is, so these are like solving matrices as well. Quadratic equations, ax, so it'll be ax squared plus bx plus c, and your cubic equation, which is ax cubed plus bx squared plus cx plus d. Okay, so let's do an example. Let's do the quadratic equation. So a, let's call it 1. Let's make this -5, and let's make this 6. That should give us the right one. Right? And there are your x and y values, and your x value and the minimum on your parabola as well. Okay, this arrow here just points to the fact that there's more on your screen. So you can use your arrow keys to go up and down on your screen. That's pretty much what equations boils down to. A very simple plug and play kind of feature, very easy to use. Are there any questions on the equation mode? Are we all still happy? Awesome. Okay. All right, let's talk about matrices before I run out of time. And this is probably why you all wanted to come and see anyway. Okay. All right, so I'm going to actually just do a matrice example on the calculator without going back to my notes. So forgive me if they don't look exactly the same. So what we're going to do is say mode, and matrices are number 5. Okay, so the first thing that you need to do in order to edit your matrix is you need to pull up a matrix. So we're going to press math, and we're going to use 1 for editing. Here you can choose the size of your matrix. So the first one is your rows, and the second one is your columns. You have an option of between 2 by 2 up to 4 by 4 matrix. In fact, 1 by 1 up to 4 by 4. But I mean, why would you do a 1 by 1 matrix? Doesn't make sense. So I'm just going to do a 3 by 3, just so that you can see all of the numbers on my screen. Okay, and we're going to press equals. Now we can input the data. So let's do 2 equals 6 equals 8 equals. I'm just making up stuff here. -4 equals 5. 7 equals. I hope my matrix actually works. 4 equals -10. And let's make this 6. Okay, cool. Once you're done typing in your matrix, what you can do is press on, and don't worry, it's not lost. Press math, and what we're going to do is store the matrix. So we're going to say 3 and 0. Now it is saved into your matrix A. All right. Now I'm going to teach you a shortcut because I like them and it just makes things so much easier to do. Okay. What we're going to do is store the name of our matrix into our calculator. So we're going to say store D1, and then we are going to press math, and we're going to choose 0 for matrix, and we're going to choose matrix A, which is 0. Now, when I press D1, it's going to give me matrix A. Okay, so instead of doing, I'll show you the long version, instead of saying math, 0 for matrix, 0 for matrix A, we're only doing D1. Same, but much quicker. Okay, now say for example, you wanted the inverse of your matrix. I actually have to go find my inverse. So we're going to say second function, and there's the inverse, and equals. And that's it. That is the inverse of your matrix. If you wanted to multiply or square your matrix, then matrix squared equals. That's it. If you wanted to, for example, say, you want to subtract matrices from each other, you can save matrix A in D1 and matrix B in D2 and so on and so forth. So there's really a lot of nice things that you can do on the calculator. If you want to find the determinant of the matrix, press math, you'll see determinant is number 4. So we can press 4 and then we say matrix A and equals, and that's the determinant of our matrix. So there's so many nice, and once you do that D1 saving thing, it just makes everything so much quicker for you as well. Okay, let me just check if there's any other thing. If you want to transpose your matrix, that's just that one. Okay, the other thing that you need to know is the row echelon form and the reduced row echelon form, okay? I'm not sure if I'm saying it right. So for those, if you go down your table, so 6 is an identity matrix. So you would just put in the dimension of, you would say, I want an identity matrix, which is a 3, which is a 3 by 3, or you want to add a dimension, or you want a random matrix. So that's all of those options. And then here with your A, you have a row echelon form. So if I say, use my memory key A, and then I say D1, it will now reduce my matrix into the format with the 100s and the thing. So it just makes it much easier to solve for your students as well. And then of course, reduced row echelon form is your B. So we can say that one. And then D1, and of course, this will just give us all the zeros and all the ones. So if you were solving a matrix, this would be a super helpful one as well. Okay. Are we all happy with matrices? It's a lot of information to take that I've done very quickly. But I mean, you can see once you understand, or once you save that D1 key, it just makes things 1,000 times faster to do on the calculator. So anyone, any questions? We're all still very happy. Fantastic. Okay, let's move on. So this is just another example of all the matrices that you can do. I just want to make sure that I haven't left anything out. Okay, great. Okay, we have reached the end. Well done, you made it. So let me just, before I see there's one chat question here. Multiply, sorry, Angie, let me just show you quickly. So back to these matrices here. Okay, so we've got our A matrix. Let's save another matrix into B. So we're going to say edit. Let's leave it as a 3 by 3. I'm just going to, in fact, let's leave this one. No, let's change it. I'm going to leave the rest as it is. Okay, and then I'm going to store it. And now I'm going to store it into matrix B. So I'm going to press. Okay, so here's my matrix A. Then I'm going to say times and math matrix 0. And I'm going to use matrix 1. And that's multiplying my first matrix with my second matrix. And that's it. And there's your answers there for you. So quick and easy. It really makes your life a lot easier on the calculator. I must say, it makes doing matrices so much easier. Okay, cool. So as you can see, I am slightly biased when I say it is perfect calculator for the AP Maths and the IEB Maths curriculum. You can order them directly from us. I will send you a special. So the recommended retail price right now for back to school is $3.99. I will send you a special which is better than that if you want to order it directly from us. Sorry, I'm recording this, so I don't want to say anymore. And then you can find them on Takealot, at P&A, at Loot, at Macro, and much more. And if you're really stuck and you just want to order them directly, we will deliver directly to your school. Okay, so if you order more than 20, we'll send them for free delivery as well. Okay, I see there's one question here. I'm just going to answer that. No problem. Okay, cool. So that is the Sharp EL-W506T. Okay, so that's the new W506. If you have students who are in grade 8 and 9 who aren't going to use all of those advanced functions, then can I suggest the W535SA? It's cheaper, it's got slightly less functions, and it's really nice for your grade 7 to 9 students who aren't doing all of those things like matrices and complex numbers and stuff. Just from an investment and a parent's perspective, this is probably a better option, okay? So what we've recently done in the last 2 years is we've actually put over 500,000 of these 535s into the Gauteng Department of Education and given them to students at no-fee schools. And we've gone and trained all of these students and all of these, I won't say all, because, you know, but we've trained a lot of these students. And what we saw between the pre and the post test and the hour of training in between is a 40% improvement. So it's really exciting to see such a great improvement with students who just had, some of them actually had calculators before, but just to see such a nice improvement is really, really exciting. So if that's something that you're interested in, you are welcome to contact me and ask me for training on the junior calculator as well. I'm also happy to do a calculator training via Zoom with your school directly. I did one last week, my first one. So proud. So you can do all of that as well. Okay, I'm just going to stop recording.